Jupiter is often called a failed star because it composed mostly of hydrogen and helium like the Sun. However, it lacks the mass needed about 80 times its current mass to sustain nuclear fusion. Studies of its isotopic composition suggest Jupiter formed within the first million years of the solar system, capturing the majority of the gas and dust before the Sun fully ignited. Did you know these things about Jupiter? There are many more things that schools don't teach you about Jupiter. In today's video, you are going to know some unknown things about Jupiter that schools did not teach you. So I am Sourashis Chakraborty, you are watching Astro Sourashis. Jupiter is the largest planet in our solar system. It's a giant ball of gas made mostly of hydrogen and helium with no solid surface. Jupiter's atmosphere is mostly made of hydrogen, about 90%, and helium, about 10%, with tiny amounts of other gases like methane, ammonia, and water vapor. Jupiter's atmosphere is full of storms and strong winds. Jupiter's atmosphere is incredibly deep, possibly thousands of kilometers thick. It doesn't have a solid surface. The deeper you go, the atmosphere gets denser and eventually transitions into a layer of liquid hydrogen under immense pressure. The Great Red Spot is a massive storm larger than Earth, raging for over 300 years. No one knows exactly why it's red, but scientists think it might be due to chemicals reacting with sunlight in the upper atmosphere. Jupiter has lightning that's up to 10,000 times stronger than ours. Interestingly, most of Jupiter's lightnings happen near its poles, unlike on Earth where it mostly occurs in the tropics. Jupiter has the strongest magnetic field of all the planets in the solar system. Its magnetic field is about 20,000 times stronger than Earth's, making it a giant magnetic shield in space. Deep inside Jupiter, there is a layer of metallic hydrogen, a rare form of hydrogen that behaves like a metal under extreme pressure. This metallic hydrogen, combined with Jupiter's rapid rotation, creates a powerful dynamo effect which generates the magnetic field. Jupiter's magnetic field extends over 3 million kilometers toward the Sun and stretches beyond Saturn's orbit on the other side. If it were visible from Earth, Jupiter's magnetosphere would appear bigger than the full moon in the night sky. The magnetic field traps a huge amount of charged particles, forming radiation belts around the planet. These belts are millions of times stronger than Earth's Van Allen belts. They are so dangerous that spacecraft have to take special precautions when flying near Jupiter to avoid damage. Io, one of Jupiter's moons, has active volcanoes that release massive amounts of sulfur and oxygen gas into space. These gases become ionized and are trapped by Jupiter's magnetic field, forming a plasma torus, a donut-shaped ring of plasma around the planet. Jupiter formed very early in the solar system history, around 4.5 billion years ago. It acted like a gatekeeper, influencing the distribution of material in the solar system. Its massive gravity prevented many smaller objects in the asteroid belt from becoming planets, shaping the solar system as we know it. Scientists believe Jupiter started forming with a solid core made from ice and rock by gathering material from the surrounding gas and dust in the solar nebula. This core was about 10 times the size of Earth before it began pulling in hydrogen and helium gas, the two lightest and the most abundant element to become the gas giant we see today. Jupiter wasn't always in its current position. Early in its formation, it might have migrated closer to the Sun before settling in its current orbit. This migration could have disrupted the orbits of other planets and leftover debris, explaining why Mars is smaller than expected and why we have the asteroid belt. Jupiter is mostly hydrogen and helium, the same materials that make up the Sun. However, it didn't have enough mass to trigger nuclear fusion, the process that powers stars. If Jupiter had been about 80 times more massive, it could have become a star, potentially turning our solar system into a binary star system. Unlike Earth, Jupiter produces a lot of its own heat. This happens because the planet is still cooling down from when it formed about 4.5 billion years ago. The leftover heat from its formation, combined with its massive size, keeps the planet warm. Jupiter receives sunlight, but it actually gives up about twice as much heat as it absorbs from the Sun. This makes it unique compared to Earth, where most of the heat comes from the Sun. Deep inside Jupiter, the intense pressure turns hydrogen gas into something called metallic hydrogen, which acts like a conductor for electricity and heat. Jupiter doesn't have distinct seasons because its axis is barely tilted only about 3 degrees. In comparison, Earth's tilt is 23.5 degrees, which gives us our seasons. Beneath Jupiter's visible clouds, the weather gets changer. The pressure becomes so high that hydrogen turns into a liquid metallic form. But scientists are still unsure how this affects the planet's weather systems. So, be sure to let me know what you think about Jupiter. I hope you enjoyed today's video. If you want to see more, subscribe the Astrosources. See you with another amazing video. Stay well and stay healthy.